Hello everybody, Mr. Hasty here again. Today we're going to continue our discussion of the behavior of waves, and we're going to start with the concept of interference. Interference is when the process of two or more waves combining into a new wave. So you can actually see this in your house right now. You can get a large pan and water and create ripples in two different spots and watch how the ripples combine. And how they combine is called an interference pattern. There are two major types of interference: constructive. Now, I'm not going to give you formal definitions here. Pictures are going to do the job better. If you have wave 1, and then you have wave 2, and notice that the crests and troughs are matching up. Make this one a little bit bigger. Then they're going to combine so that to make an even larger wave. They're going to add the amplitudes together in the same pattern. And that's called constructive interference. Now, when this happens with sound waves, it actually results in louder sounds. And if you remember, sound waves are compression waves. So the two waves there would look like you have your compression and then your rarefaction, then your compression again, and then your rarefaction. So they would have to line up in the same way: compression, rarefaction, compression, rarefaction. And so they would combine and actually make louder sounds. Now with light, it actually makes brighter light with light waves. And with mechanical waves like ocean waves, you can actually get larger waves created by two smaller waves if they are in a constructive pattern. And that means that their crests all line up and their troughs all line up. So what's the other type? I'm going to clear this. The other type is what we call destructive interference. And destructive interference is basically the waves canceling each other out. So if I have this wave here, and I have the exact opposite, this is a little tricky to draw. Then they can completely cancel each other out, or at the very least make a smaller wave. Now with light waves, this is very tricky, and we're not used to seeing this, but they can actually interfere with each other and make they won't make the light not visible, but they'll make the light patterns appear differently. We'll talk about that in a second. With sound, they make quieter sounds. This is how dampening chambers work. And with waves, this is why you can have waves in one part of the ocean and waves in the other part of the ocean. They can cancel each other out to make a calmer part of the ocean in the middle. Now, an interesting experiment, and you could do this if you have blinds in your house. So if you pass light through one slit, like a single slit, you'll get the light waves kind of going off and doing their normal thing. They behave similarly unless that slit gets very, very small. But if you have two or more, and you can simulate this using the blinds in your house, you'll get these kind of banded patterns on the wall where you have a light area, then a dark area, then another light area, then another dark area. And that's because the light areas are where there's constructive interference, and the dark areas are where there are destructive interference. And this is actually the basis for a famous experiment with light and electromagnetism called Young's double slit experiment. We don't need to know that experiment, but it's kind of the lead into that concept. All right, we're going to move on to our second concept. Actually, before we move on, let's talk about an interesting experience that you might have had. Let's say you're on a trampoline. Well, trampoline creates a wave pattern. And if you've ever done a double jump on a trampoline, what you're actually doing is creating constructive interference, where the way one person creates a wave and the other person creates a synchronized wave so that you can jump, essentially use a wave that is bigger, of greater amplitude than what you could do on your own. Our next concept is standing waves. And you can create a standing wave in your house. All you have to do is find something to attach a string or a spring to and shake it. And it will shake until it hits an object, and then it will kind of reverberate back upon itself. If you play a guitar or any stringed instrument, most instruments make use of a standing wave. So if we have a guitar string and we pluck that string, we're essentially making a wave, and that wave will rebound off the other end, and that is used to make a lot of sound. In woodwind instruments, we do it with a column of air instead of a fixed string, that column of air that is inside the instrument. What a standing wave is it's a wave that does not move in space. So when you play your guitar, there's vibration in the string, but that string is not moving to the left or right. It's just staying right there. All right. Now, in any standing wave, they have what are called nodes. And nodes are places where the initial wave and opposite wave cancel. Essentially the places where you have zero amplitude on your wave, where it just stays stationary. Now we're going to move on to one of the most important concepts with waves from a practical engineering standpoint, and that is resonance. Resonance is a process where waves of a certain frequency create vibrations in an object. Now remember, waves are transferences of energy. So when you think of a physical wave, it's actually a transference of energy. So one of the classic examples that people think of is a singer breaking glass with their voice. Now, if you can make a piece of glass resonate, use resonance, at the key frequency for that glass, it'll start to vibrate. And if things vibrate enough with enough energy, they will break apart. There have actually been stories of groups of soldiers marching across bridges. And when you march, you tend to do it in time. So you create this frequency of footsteps. Left, right, bump, 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 bump. And that actually resulted in, if you hit the natural frequency of that bridge, then what's going to happen is that bridge is going to start vibrating on its own, and it can start to break apart. And there have actually been stories of groups of people marching across bridges in form, creating a very rhythmic pattern, and then that bridge breaking down because of that. Another example of this in sound waves is if you take a tuning fork that's supposed to be at a certain pitch, let's say it's supposed to be at the note C, and you have another tuning fork that's at the same pitch, pretend like these are the same size, I can't draw. If we bust this one up and create some waves, when those waves hit that tuning fork, it's going to vibrate that tuning fork, and it's going to start vibrating at the same frequency. Another example of this is your microwave. Your microwave releases microwaves, which are electromagnetic radiation. And what they really do when you put your bowl of whatever in there is they heat up the water particles. So there's all these water particles typically in food. Almost all food has some form of water in it. And if the food doesn't, the air certainly does. And as the waves come out, they vibrate those particles. And if you remember us talking about heat, really what heat is the movement of particles. So by using these waves to vibrate water molecules, they're really vibrating molecules, which is creating heat. And so all these are different phenomenon associated with waves. So let's do a quick recap. We have interference. If things interfere in the right way so that they get bigger, it's called constructive. If they interfere where they are opposite of each other, where the crust lines up with the trough, then they are destructive and they will get smaller. Constructive bigger, destructive smaller. A standing wave is a wave that is moving through time but not through space. So a guitar string fixed on both ends but vibrating. And as it vibrates, it has notes, places where it is pretty much still. And finally, resonance. When waves of one frequency cause an object to start vibrating, create mechanical vibration through some other form of energy, usually sound waves or light waves, not light waves, microwaves, or something along those lines. All right. So that covers all of our concepts having to do with the behavior of waves, and I'll see you next time.